Hello everyone. So one of the last videos we spoke about strings. We talked about how they work and what kind of operations we can do on them, like multiplication and adding strings to other strings. But now we will make a small recap of all that we've learned and then go on into more details about strings and different operations methods that we can use on them. So the first thing that we need to remember is that strings are in between apostrophes, which can be the two apostrophes or just the one, like here, Saul Goodman, like this. But I usually use two apostrophes, so it looks a little better in code. And a string is a string of characters. It means a line of characters, a number that can be however long or short that you may want it. So here I've created a variable that is called best lawyer, and in it I've stored a value of string, which is Saul Goodman. The way that it is stored is that every character in the string has its own personal index. So for example, S is 0, A is 1, U is 2, and so on until the last character, which is 11. You can also write the indexes in a negative number. If you use -1, for example, it will start from the end of the string. So -1 position index is the N, -2 is the A, like here that we have it written down. But you notice that there is one small difference. The highest number here with positive indexes is 11, while negative ones is -12. The reason for that is because the first character is denoted by a 0 index, whereas the last character in negative indices is with a -1. So one thing that we've got to remember is also, please note this, that even the space is one character and it has its own index. So let's say we want to splice this string into substrings. So we don't want the space and the Goodman part, we just want the name, Saul. So the way we did that is by splicing it with square brackets. So what we do is we write it down like this. Best lawyer is, okay, let's do the brackets. Best lawyer 0 until the stop index. So this is the start index. It says that start from the index number 0 and then go up to, but do not include the stop index. So the stop index is never included in the last portion. So this would be 4 in order for us to get only Saul. Why? Because the stop index is never included. Let's see it like this. So if we start from the 0 and then we tell it to go up to the 4 but don't include it, it will take up only Saul. So if we print this way, this variable written in this way, we will result only Saul. So let's check it up on Visual Studio Code. Now I've written something here. Let's delete it. So let's say I want it to display only the name. We write print and then the variable. If we print it as it is now, we will see that we get the whole name, but we want only Saul. We remember that it was from 0 to 4. Okay, when we check it now, it is Saul. What happens if we write the number 3 here? Let's check it out here. We should get only Saul, only the L being left out. So we got this point. The stop index is never included when we are splicing a string into substrings. Great. But is there anything else that we can add into these squarish brackets? Of course, there is also one other index, which is the step index. So it's divided into start index, stop index, and the step. The step is basically, you can tell it to leave out every other character when you want to print something out. For example, let's say that we want the whole Saul Goodman name, but we want to leave out every other character. So what we do is you start with 0. You go on indefinitely, so we don't write anything down, because if we wrote 11, it wouldn't include the N. It would include everything up to the 11th character, but leave out the 11th one. So in order to have everything included until the end, we just leave it like this. And the second column tells us that this last number that we write in is the step one. So for it to print the first one, then leave out the A, and then print out the U, and so on and so forth, we need to write the number 2. So it means every other character should be printed. So let's try that out. Let's do it like this. So we've got it like this. So it should be SU space and so on. Let's check it. SU space ODA. So that's what we did, because the number 2 here, the step, makes it print out every other character. So the first one that's printed is S, leave A out, then U, leave L out, then space, leave G out, then O, then leave the other O out, then print D, leave M out, then A. So SU space OD A. Let's check it once again. Is that what we got here? Yes, that's exactly it. Can we do other things? Of course, we can increase the step count to 3, and it would do the same. It just would leave out 2 characters in between. So let's check it once again. So SL, it means A and U have been left out. The L, the third character, has been printed. And then, and so on. So it means space and G would be left out, then O, and so on and so forth. You get the concept. It's nothing more complicated than that. But we can do more interesting things. We were talking that, we said that if we write -1 like this, it would tell that you should go on from the end of the string and the last position should be printed out. So let's check it out. So we see that the last position is the N, and here we get it, the N is printed out. We can do that with -5 and check it out. It's a O. Let's check out. So -5 is O. We can write the same index as a positive number, is the number 7, and we would get the same result because it doesn't matter if the index is in a negative fashion or just a positive one. It just has to match up with the index that with the character that you intend to show. So we get it. We can print out negative indices, but what happens if we print out a negative step? So if we do this, what it will tell the computer is to go from the ending of the string and start printing it backwards. So Saul Goodman would be something with NAM, DOOG, and so on and so forth. Let's check. So it's Namduk Lewis. Okay, so you can even print it out in minus step count. You can do that with -2, which means that it would leave out every other character. So N, M, O, GLA, and that's it. So there are different ways of splicing strings into substrings, but what we need to remember is this. We have a variable which has a start, end, and a step count. So it's start index, end index, step count, or step index, doesn't matter how you call it. I don't really care about the particular terminology. It's just so you know what it does and how it operates. So that would be everything for these little tidbits, but we need to get into specific operations that you can do or methods that you can use using strings. So there is this len one. What len does is it basically counts the number of characters in a string. So we saw that Saul Goodman was like 11 characters long. Let's check it out. Let's len, and we open the brackets or parentheses or whatever, and we write inside of it the variable. If we try to run the code, what happens? We don't get anything. The reason for that is we didn't print it out. So we write another print and put it inside its parentheses. When we print it out right now, we get 12. Remember, I said 11. Why? Because in my case, let's check it. Where do we have it now? We started at the index number 0, but the total count of characters is actually 12. So when you count it, 1, 2, 3, 4, 5, blah, 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 we get 12 characters. And that's what len does. It counts the characters within a string. So let's suppose we write out a great line, a very big line. Let's say blah, blah. And we write out blah, 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 blah. And then blah, 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 yada, 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 yada. Okay, we don't know how many characters are in the string, and let's suppose it's very, very important for us to know. We would use len, this len operation or whatever, onto blah, blah. And we check it out, and we get the number. It's 52. We have written 52 characters into this string. So this might be important sometimes because let's say you want to make your client write in a username, but you want to limit it into 12 characters. Then you can make what if else statement. If the characters are above 12, you don't allow it, or if it is below, then that's okay. And you would need to know the number of characters in the strings. So len is used for one simple thing. It counts number of characters. Good. Is it the only thing that len does? No, we will learn in the future. Like I just talked also about if-else statements. That's something that we will get into in the future. But len can be used also in tuples and lists, where you count the number of individual elements in the list or tuple. Yeah, so that's about len. we finished it, so let's cross it out. We will go with the upper and lower. The upper and lower is pretty straightforward. What does it do? It just turns everything into uppercase. So let's change it. So we had len here. The way that we wrote len is that we had to write len, open the brackets, and put the variable inside. But the upper and lower have these dots here in front. That's why it's called also dot notation, because it's a method or operation performed on a variable by adding a dot in front of it. So for example, we have here blah blah blah. We would do blah blah, then a dot, and write upper and do the parentheses. So let's delete this and put it inside the print statement, and then let's do it. Here what happened is blah 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 yada yada yada, and everything is written in uppercase. Here, if we change this, the whole line, we turned it into uppercase. Let's copy and delete, paste this other one. Let's say now we want everything to be in lowercase. What do we write? Pretty straightforward. We exchange the upper with lower and do the parentheses and then print it out, and we will get blah 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 yada yada yada, and everything will be in lowercase. So yeah, these two were also very straightforward, and I bet that every one of you is thinking, wow, this is so easy peasy. It is, but it still requires time from you to test it out and write it out and check out different kinds of exercises in order for you to soak them in and just to never forget them. So the other one is capitalize and swap case. Capitalize just capitalizes the first character of the string, but let's do it. Let's write down this all in lowercase. Let's check it out like this. Okay, and now we want to capitalize. Let's check it out, and you see the very first character, it gets capitalized. Good. What can we do else with it is we also can swap cases. It means that every case, whether upper or lowercase, will be turned into the other one. So let's say that we write it down like this. Okay, my first name is uppercase and the last name is lowercase. So when we write the dot notation for swap case, what we get is the opposite. So Drillon is written in lowercase and Maloku is written in uppercase. So we also did this, not so very difficult. We have find and rfind. These two are used to find specific characters within a string or set of characters within the string. How would that work is in the following. So let's say blah blah is Drillon Maloku, and I want to check for the first O that appears in this text. In that case, I would use find and then write within the parentheses, write the character that I'm searching within the apostrophes. So it says the number 10, so it means that in the 10th locus there should be the O. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what it did is, I think it did the opposite. Let's check the reverse find, but it also says O. Why? Because this is a different string from this one. Because I specifically wrote lowercase o. But let's check it this way. Let's write it lowercase o and run it. So rfind finds this character starting from the end of the string. But if we remove the r for reverse, it will find that the character o is in the fourth position or index. 0, 1, 2, 3, and o is the fourth. So find and rfind are used to find the position of a certain set of characters. In the last example, we wrote only o, and now I added the uppercase n. When I check it now, we will see that on starts at the fourth index. 0, 1, 2, 3, fourth. Okay, it starts and it is written onwards. Let's try and check it from rfind. Let's see what it says. It says the same thing because it starts at the fourth locus. The only difference will be that rfind will take a little longer in processing power because it starts from the ending where there are many more characters in order to get to the on string of characters. So that's this part. We finished find and rfind, and then we have the dot replace, dot notation, and dot count. What that does, let's do it with the dot count. It is very easy to see it here because there are 2 O's, and now we want to count the number of O's. Let's run it like this. We see that the number is 2. We can also check the number of OKs within this string of characters, and we see that there is only one OK here. So count counts the number of times one set of characters appears within a string, or just one simple character. And the other one was .replace. Let's say I want to replace Maloku for something else. Let's replace Maloku with the string. You need to write it like this. So the first one is the one getting replaced. The second one is the string of characters that it is replaced with. Maloku Babloku. Let's check it out. When we print it out, Drillon Babloku, because Maloku has been replaced with Babloku, and that's it. Now we finished every single one of these operations or methods or dot notations, whatever you want to call them. Basically, they are differentiated between them, but I never found it useful to know the specific ways that they are different, especially in the beginning, because everyone who wants to learn programming is focused to just get to the point and create small programs, and that's just a factor that makes you more enthusiastic about getting on with learning programming. So that's something that you shouldn't worry at this stage. I wouldn't do it, but that's just me. The books really try to hammer it in from the beginning and early on. And yeah, it's just my personal opinion. You should go on however you see fit. But if you want to learn it with a book, please remember that book, Get Programming from Annabelle. It's a great book. Is a substring within a string, yes or no? So this is a personal note to myself. I wanted to explain what in is. For example, we want to find out if a specific set of characters is within a string or not. Let's say I want to make sure that on is within this string blah blah blah. The way that we would write it is on in blah blah. Now, when we run it, nothing happens. Why? Because when we write this down, this computes into a boolean, which is a true or false object. The way that it computes into true or false is it checks if on is within this piece of text, and if it is, then it is of value true. If it isn't, then it is false. But we also need to print it out in order to see it. So we print this, and you will see that it computes into true. So this operator called in checks if something is in something else. So it's pretty straightforward and easy. All of it up until now was very easy and very logical. I know that, but please believe me that you will need to go on and just test each and every one of them and see how they operate, because there are some outskirt situations, borderline situations where you don't really realize how they work unless you try it out for yourself. So that's for this video. Yeah, we hear us on the next one. Bye.